session. In this session, I will focus on the case studies of artificial intelligence. Today morning also you have seen two different studies. One is associated with sentiment analysis. Another is associated with natural language processing. In fact, my talk is also more or less related to that topic or requires some extension of that particular topic. So, as the name suggests, here I will focus on the recommender system. So as you know that recommender system, this word, and whenever we are reading this word, one thing come into our mind that there is a recommendation. Generally, whenever we are applying for some job, or whenever we are going for abroad for some, let's say postdoc or PhD or master courses, our students are asking us to fill up a recommendation form. Okay, so why they are filling this recommendation form? They are filling this recommendation form in which we have to specify the behavior of a student, how the student look like, how the student, whether the student can study that particular subject or not, and whether the student is capable to speak in English, what is the analytical capability, what is the what about emotion of that student. Many criteria they are evaluating. So basically, we are filling the recommendation system. Generally, we write in favor of our student. Similarly, in our real life also nowadays, social networking is much more powerful. At the same time, online shopping also having much more powerful. So I will focus on these online shoppings. Like most of the time, we purchase item from Flipkart or Amazon or eBay or some other websites. So how they are actually giving these products and how they are recording our responses in order to provide some future recommendation. Basically, my objective is to focus on this particular part. So I will focus on this session about introduction of the recommendation system, why we need recommendation system, and various types of recommendation system, and how to develop a recommendation system. Once you develop a recommendation system, how to evaluate whether the recommendation system is performing well or not, then followed by some conclusion and selected references. So it is not possible to cover this lecture, entire lecture in this session, because it is a 5 days course, recommendation system. Only my objective is to highlight on the recommendation system and tell you some problems so that interested participant can look further about this particular topic. So before going to the recommendation system, the question generally arises because in this workshop also we have studied so many technologies associated with artificial intelligence. So how to know whether a particular technology is an emerging in our marketplace or not? So for this, there is a Gartner hype cycle is there. So Gartner is a company. So generally it is a multinational company which is based upon the ICT products. ICT stands for Information Communication Technology product. So they are predicting the future of the various technologies. So this is the latest cycle released by Gartner in 2019. Although they are releasing these cycles twice in a year, the recent one is 2020 January, but it is not published publicly. So I am unable to show you that the latest graph. But the previous one that is released in August 2019 is this particular graph, whatever you are seeing. So this company generally show the hype cycle. Okay, this why it is called a hype cycle is based upon the structure of this cycle. It is called as a hype cycle. Hype means which technology is emerging. So if you see this particular graph, let me zoom it so that you can clearly see. Okay, in x-axis, if you see, time is there. Okay, x-axis time is there. Y-axis expectation is there, right? Time means, for example, 2 year is a time, 5 year is a time, 10-year time. What should be the expectation of the market? What market is expecting? Okay, so it is giving the various technologies and their life period in the market. So if you see this particular graph, okay, this particular hype cycle, you see 5G technology nowadays is very popular. So 5G is present here. Here it is present artificial intelligence PaaS. So PaaS stands for platform as a service. It is a type of service provided by cloud computing. So AI with combination with PaaS. So that is combining is called as a AIPS is in the very top cycle. So whenever a new emerging technology is coming into the market, so it is present in the innovation trigger part. Innovation trigger means in this part, bottom part of the hype cycle. Okay, gradually the technology will grow. People will start working in that particular technologies, right? So people will come to know about like 5G is now a common term. People are working in 6G, right? So like that, these technology will grow once it will reach to in the top of the cycle. That is called as the peak of the cycle. After some time, the technology will obsolete. Nobody will nobody is interested to learn that particular technology. So similarly, if you go for artificial intelligence, a very emerging technique is called autonomous driving level 4. It is a old technology that is based upon autonomous vehicle driving. What it indicates, it is divided into 6 levels as per my knowledge, right? It is starting from level 0 to level 5. Level 0 indicates there is no automation. There is completely no automation. Like we are doing our work in Microsoft Excel. So this is a complete manual system. There is no automatic system. But level 5 is the highest level, which indicate that human intervention is not required. Your vehicle will go in its own way. By it has camera, it has radar, it has many things. Okay, so our vehicle will automatically go in a particular road without any with assistance of our human being, right? So level 5 is the top one, but till now it is such type of vehicle was not developed, right? So our objective is to reach to level 5, starting from level 0 to level 5. So level 5 is full automation, where level 0 is our completely manual work, right? So level 4 we have already achieved. Okay, so that is present here. So it is going from the peak level to the slope of enlightenment. Okay, that is absolute technology, but level 5 is now in growing phase, right? So level 5 we are expecting that no driver is required in our vehicle, right? Right, that vehicle will automatically go without any assistance of human being. Okay. So now, why I am showing this particular technology, this particular hype cycle? You see, maximum technology that is present here in the top of the cycle, that is more or less related to artificial intelligence, or you can say machine learning, or deep learning, or the associated technology of artificial intelligence. See here there is artificial intelligence pass is there. Here explainable AI is there. Here edge AI is there. Autonomous driving levels is there. So these are more or less associated with our artificial intelligence and techniques developed in the artificial intelligence. So there is a future. That is my objective of saying this one is that there is a future of artificial intelligence. That's why people are interested in developing solutions for these particular domains. Similarly, you see these are the yellow dots, right? So if you come to the bottom of this particular hype cycle, see here these yellow techniques are the life period of these yellow techniques are 5 to 10 years, right? For example, if you see here, it is AR cloud, that is augmented reality and virtual reality cloud, right? AR VR cloud is present here. What it indicates, AR cloud will be emerging in the market for 5 to 10 years. But if you see the black dot, right? This is a black dot, right? That is 3D sensing camera. It will be sustained in the market for 2 to 5 years. Similarly, white dot indicates it will sustain in the market for less to 2 years because it is already emerging and now it is in the absolute phase. So if you see autonomous driving level 4 is present in the life period of this particular technology is less than 2 years. So based on that also we can suggest our BTech student, MTech student and PhD student to do work if they are interested in artificial intelligence, what topic they should choose for their project work. Next, this is the marketing perspective. The Gartner released the cycle for marketing perspective. If you see marketing perspective, AI in the very peak level. AI for marketing is very top level, right? It is exactly in the peak level. And other technologies are also associated with artificial intelligence, like mobile wallet marketing. Nowadays we have Phone Pay and Google Pay, right? So many Bhim app is there, right? So we are using our wallet to perform marketing, right? And customer data platform, real time marketing. These are in the very top phase. So this graph is a little bit different from the previous one. The previous one is for the research community R&D, but this is only for the marketing and advertising. Now come to the recommendation system. I will tell you in Google you can search Google Trends, Google search trend, right? If you search in the Google search trend, so similarly one tab will come like whenever we have some doubt in the doubt or we want to learn some particular topic. So generally we search in the Google, right? So similarly in Google search trend, if you type recommendation system and set the limit from 2004 to present, so whenever you visit this Google search trend, you can type any word to know that what is the popularity of that particular word. So you can visit now also. So as there are so many slides are there, so I'm not giving you time to visit that particular. So you make a note that Google search trend you have to visit. You have to type recommendation system. You can restrict your search to India. You can restrict your search to let's say in some other countries, or you can open it to whole worldwide. Worldwide also you can see what is the popularity of a particular word. So if you see from 2004 to present, what is the scenario? If you see this bottom one, this part, this is nothing but 2004 and this is nothing but 2017. We are present here somehow here 2019. If you see the graph is more or less now increasing. The reason of increasing this particular graph is that people are now interested in digital marketing and digital advertising, right? That's why these recommendations words are people are searching in the Google, right? What they want to know, what is the why, what is the technology of recommendation system, and what people are doing in the recommendation system. Similarly, in this particular website, Google Search Trend, you can also see that which country the people are searching this particular keyword. If you selected worldwide, which country is searching this keyword very frequently? If you see, Iran is getting a score of 100, South Korea is 97, China is 74, Singapore is 57, India is present in the 54th position. So you may get different result if you search in the Google with respect to time. This graph will be changed, right? Means some more data. For example, this is the graph for 2018. So 2019, 10, 20 data is added into this particular graph. Then you will see the graph is little bit change in this particular graph. But past data remains same, right? So here, what it indicates, Iran is having 100 score, but India is having 54 score. What it indicates, they are calculating the percentile concept. Percentile means if highest mark, suppose for example you conducted some exam, the total mark is 100, right? But the highest mark secured is 38. So 38 is now I will consider as 100, right? That is the percentile system. So 38 student is now converted to 100 because 38 student is 30 mark, it is the highest mark in my class, right? Accordingly, I will scale other marks out of 100, right? Similarly, the search query received from Iran, country Iran, if I calculate it is 100, what is the score of India? India's score is 54. So these values are indicates the search query out of 100. It does not mean that 100 billion people are searching or 100 million people are searching this particular query. Now come to what people are actually searching. So whenever we assign generally a new topic to our BTech student, MTech student or PhD student, for example, I will tell my student to search in quantum computing, right? He has no knowledge about quantum computing. What he will search? He will search quantum computing PPT, quantum computing PDF, what is quantum computing, why computing, such type of query will come, right? Similarly, these are the popular queries in the Google. People are searching recommender system, some people are searching recommendation system, some people are searching recommendation, some people are searching for Python recommendation system, where Python is a very popular programming language. And nowadays very popular, people are using Python. And another word is collaborative filtering. This collaborative filtering is a type of recommendation system which I will tell you later. So similarly, there are search query indexes, recommendation system, most of the people are searching. The index value is 100. Similarly, collaborative filtering having a value of 44. Similarly, what are the related topics of the recommendation system? If you see recommender system, hyphen topic, okay, system topic, data topic, Python programming language, collaborative filtering topic. So like that you can find. For example, nowadays you know our COVID scenario is going on. So you can search, you go to Google search trend, you type COVID-19, okay. or you search about coronavirus. So you will see the popularity of this word in a particular country, in a particular state also, or you can say in a particular region, or you can say all over the worldwide. And you can also see which country is searching this coronavirus word or COVID-19 word at most. That also you can see this slide. Similarly, you will see what are the query people are asking in the Google about coronavirus. That also you can get in the related queries, and the related topics of the coronavirus will be appeared here. Similarly, you can search any type of word, but don't paste the common person's name, right? Because the common person name is not that much popular. You can type Prime Minister of India, Prime Minister of US, okay, President of US. Okay, that is possible, but don't type your name because it will not appear because that name is not that much popular. Now, coming to the definition, what is a recommendation system? Before going to the recommender system, in my some slide, you will say I have written recommender system. Some slide I have written recommendation system. Sometimes I am writing recommender platform, recommender engine. Okay, that's why I have written recommender and recommendation. You can use any word because they are same. You can also use any word, system, platform, engine. Any word you can choose. For example, somebody will say recommender system, somebody will say recommendation engine. Okay, so don't be confused with this word. Recommender, recommendation, both are same. Okay, and you have to choose one word from this basket: system or platform or engine. So, like generally, I give an example of Facebook. If you go for Facebook, the number of users of Facebook is not not small, right? Many users are there, which is you can say a very big number will come. Right, some billion, some trillion people are there in the Facebook. So if I get the data of the Facebook, right, Facebook data, if I give you of these many users, it is very difficult to process this data. Like I told you in the genetic algorithm also, if you go for 16 to the power 512 number of solutions, it is practically not possible to solve a particular problem. So what we are doing, instead of going for 16 to the power 512, we are using only 100, right? So in the previous example, you have seen 16 instead of going for 16 to the power 512 or 10 to the power 512, I am relaxing to 100. So I will process these 100 attributes, 100 rows, right, or 100 chromosomes. Whatever performance I will achieve, I just want that the value should be close to optimal. If the value is 2, your value should be close to optimal. Similarly, in the recommendation system, irrespective of the field, you should not apply to very big database. It is practically not possible, right? Big database, because while you are analyzing something in the database, at the same time some new data is also generated. For example, I will give you a Facebook data. By the time I am giving, also people are posting various posts. People are sharing the various posts in the Facebook. So it is not possible to capture the data and send to you for the analysis. So what we are interested? We are interested for a subclass of the system. Rather than going for an entire class, I will go for a subclass of system. For example, we have 200 participants here. So it is not possible to listen all the participants one by one about the feedback. So what I'll do, I'll randomly ask 6 people to give the feedback. If 6 people are giving good feedback, then it indicates that the workshop is good. Okay. So that's why we are not interested for the class. The class is nothing but a big one, 16 to the power 512. Rather than I am interested for a subclass. So rather than going for a so many users of the Facebook, what I will do, I will take a data of let's say 1000 people of the Facebook and I will try to analyze the data. That's why recommendation system definition says that it is a subclass of information filtering system. We are not interested for class, we are interested for a subclass. It may happen that you can take different 100 sample and your result is better than me. It may happen, right? Or more or less your result and my result is same, right? So subclass selection is also a very important part, right? How we will select these 6 people out of 200 participants? That is also an important question, right? But irrespective of because it is practically not possible to go for 200 participants or 16 to the power 512. So what we are doing? We are only selecting a subclass of the people, right? Or subclass of any information filtering system. So why it is called filtering system? Like we have a filter, right? We are using filter to get pure water, right? Similarly, here recommendation system uses various filter to screen the information, right? So that we'll see in the form of example, so that people will enjoy this particular topic, right? So the definition says that we are not interested for a class of information filtering system. We are interested for a subclass of the system. So what is the objective of this recommendation system? Whenever we purchase a particular product, you know that whenever we are purchasing some product in Facebook, sorry, in Flipkart or Amazon, what we are doing? Once the product is delivered to us, they are sending a feedback form, generally in the form of stars followed by some text you have to write. Like in our feedback form also, we have mentioned 14, 15 questionnaires followed by some paragraph type question. So people can write in the paragraph type question if they are interested, and they will rate out of 1 to 5 or something like that. They can write. So the main objective of the recommendation system is to predict the rating or preference of a particular user that the user would give to a particular item. So whenever a user is purchasing an item, whatever feedback the user will give to or to give the recommendation system or to the Amazon or to the Flipkart, that we have to guess. So some kind of prediction you have to do, right? Suppose one computer is delivered to a particular user or a customer. Okay, so once the customer receives that particular computer system, how much he will rate out of 5 or out of 10, how much rating he will give, that we have to predict. That's why a recommendation system do some kind of prediction. Either prediction is based on the rating or it may be based on the preference of a particular user. So these are the two important definition of the recommendation system. And you know, most of the people are now familiar with Facebook, Twitter, Amazon, Flipkart, eBay, Levi's, Netflix. We are watching movie, right? YouTube. We are listening various musics, movies. Many things we are learning from YouTube, right? Spotify. These are the various applications of the recommendation system. So whenever before going to the other slides, so let me tell you, whenever I'm telling item is same as item. You can consider item is a book, item may be a computer system, item may be any purchase item, whatever available in the Flipkart or in Lenskart or in any other website. In general term is it is item. Don't indicate that the item is a food item or a book item. It may be generalized. It may be anything, right? So now coming to the architecture of a recommendation system, later I will give you a deep architecture and close analysis of the architecture. For the time being, I will show you a very simple architecture here. So there are 4 components in the architecture, right? If as you can see, there are 4 components, right? So here a user is present, right? Suppose I want to purchase a computer system from Flipkart. So I am a user, right? I am purchasing. I am logging into Flipkart. I have created my account. I am searching for some computer system. So user has a major role in the recommendation system. So you are using a recommendation system. This recommendation system is what? This recommendation system is nothing but my. This recommendation system is nothing but Flipkart, right? Or you can say Amazon or any shopping website, right? So I am searching in Flipkart. That's why my recommendation system is Flipkart. So how Flipkart is giving some suggestion to me, okay, or how Flipkart is giving some answer based upon my query, or it is showing a set of computer system. It is based upon a particular database, right? They have their database. They have my login, username, password, what item I have already purchased. Okay, what item I am searching, what should be the recommendation, what should be the new item they should suggest to me. That is based upon my database, right? So the first component is the user, right? Second component of the system is recommendation system itself. So that is nothing but in computer science term, I can say this is a algorithm, right? Algorithm, or if you don't understand algorithm, you can say any type of system. Okay, it may be hardware system, it may be software system. Generally, we are referring as a software system. It is providing some kind of recommendation based upon the database, right? Then what it is suggesting? While I am searching some computer system, it is giving some details about the computer system. It will show some computer system of HP, some computer system of Dell, Acer. So many companies are there. So based upon my search query, if I search query that 4 GB is required, so they will search accordingly in their database, and they will give a list of computer system that is having 4 GB of RAM. or 1 TB of hard disk or i3 processor or i10 processor. Like that they will give to gives a set of recommendation to me. Okay, that's why recommendation system is having four component: user, database, system, and a set of recommendation system. Okay, so generally, if you see, as I mentioned here, we have to predict the rating. Okay, we have to predict the rating. Before prediction of the rating, you require some historical data. For example, tomorrow I will say that tomorrow there is a rain in Telangana. Okay, so how I am saying that tomorrow there is a rain? Because of the previous history, right? Previous history, I'm recording the previous history. I'm recording the today's temperature, yesterday's temperature, day before yesterday temperature. In each and every time, humidity also I'm calculating, temperature I'm calculating. Based upon that, I analyze that there is a prediction of rain, right? Similarly, here also, whenever a user is searching or whenever a user is giving some kind of rating, before that you have to predict that how much the user will give. For example, let us consider a informal example. For example, let us consider our education system in which a student appeared for a particular exam. Let's say the student assumed that his CGPA is 9.1, right? This is the student's expectation, right? That we do not know, right? I will ask the recommendation system what should be the CGPA of that particular student. So recommendation system saying it should be 8.9. The student appeared the exam and his score is 9.1, but recommendation system is suggesting 8.9. So more or less they are same, or you can say the error is the difference of 9.1 and 8.9, that you can say 0.2, right? So similarly, recommendation system will give you some kind of rating, but that rating may be different from a user rating. The difference of the user rating and the recommendation system rating can be called as a error. I will tell you this calculation so that it is more clear. So let me cover the architecture part first. Similarly, in this example, the user has searched to something about movie, right? Then the recommendation system has seen database, right? In database, user history is there. Whatever the item is, whatever the movies seen by that particular user. Okay, so that is recorded in the database. Based upon this record database, recommendation system suggests that these two movies are appropriate for this particular user. If the user will like these two movies, then he will give a rating close to 5 in a 1 to 5 scale. So what we need here, we need a artificial intelligence system, right, or a machine learning system. That's why system should be that much intelligent to provide such a recommendation. That's why we require an intelligent system or generic or any specific machine learning techniques in order to improve the recommendations, right? So we can apply any kind of machine learning techniques. All the peoples are already applied in various techniques, AI and machine learning techniques in the recommendation system to get the good recommendation. If whatever user is giving, whatever recommendation is giving, both are same, then your accuracy is 100%. Like a student is expectation is 9.1, a teacher is also giving 9.1, it means the accuracy is 100%, right? Now, in which domain you can apply recommendation system? You can apply in movie domain, right? So, you take a movie database, okay? After taking a movie database, first you check what type of movies a particular user like. So, based on that, you suggest a set of movies to a particular user, right? Like nowadays we are getting mail from Book My Show, right, or Paytm. We are getting emails related to a particular movie, right? With some coupons are also they are giving. Okay, what is how they are getting this one? Because of this database. They have your database. They know what type of movie you will like, or whether you are frequently watching the movie or not. So based on that, this analysis, they are suggesting some movies to you. So you can apply in the movie domain, right? For example, you can go for Netflix. Netflix is a very popular site. Nowadays, people are watching movie in the Netflix, Film Affinity or Movie Lens. These are the various websites that you can visit for movie. You can also apply in the news domain, right? News domain, how will apply? For example, I am interested for political news, right? I am very much interested to know the political news. So the recommendation system database know that I am also always searching the news related to politics. So whenever a news related to politics will come tomorrow, the same news will be they will drop to my email ID. Okay. that this prime minister has done this thing or chief minister has done this thing, so that you can get some idea about that particular domain, right? Similarly, people are now interested for music domain also. You are already you may be aware of the Geo7 app, right? Like many maximum users are now using Geo phones, right? So there is a Geo7 app. In Geo7 app, whatever movie, whatever songs you are listening very frequently, right? Suppose I have started my Geo7 app, I have played one music, right? So that while you are playing a particular music, once that particular music is over, for example, after 5 minutes, the music will be over, right? So what should be the next music? The next music will depend upon your previous experience. What is your previous experience? The previous experience is that which music you have already you are listening very repeatedly. Okay, that music will be played. Okay, or based upon the current music, the next music related to that will be played. For example, you are listening a music of X movie, then X the musics of the other musics of the X will be the next, right? So similarly, you can apply recommendation system to any other domains also. For example, now I am interested. I am also working in that area. Like students, if you go for BTech students, BTech students are learning around 20 subjects, right? Before coming to the final year or pre-final year, they are learning 20 subjects. In final year or pre-final year, we have a set of elective courses, right? So what we will do, we know that in which course the student is performing well, right? That history we have, right? We know the student's mark in each and every subject. So from that I can say that a student is good in mathematics, or a student is good in physics, or a student is good in chemistry. Like that I can say, right? Okay. So like that, I can say different subjects, right? That he's good in X domain or good in Y domain. So accordingly, I will select the elective subject for that particular student. I will recommend that if you choose recommendation system as your elective subject, you will do well, or it will be helpful for your project. Or you can say that based upon the elective subject or regular subject, I will suggest what kind of research work the student should do, right? Such kind of recommendation also you can do by the help of recommendation system, right? So let me see some questions maybe posted here. So let me see, is there any question? No. Okay. Okay. So what we need to focus in the recommendation system. Each box has a question, right? So I told you the architecture is consists of four component. One is user, another is database, another is recommendation system, another is a set of item. Those who are not comfortable in the database or not belongs to computer science domain, they simply assume that database is something like, you can say, Microsoft SS. If you are not aware of Microsoft SS, you simply assume that there is a Excel sheet. So I have said on Excel sheet to you to give a illustration of this recommendation system. So you simply assume that there is a Excel sheet present here. By analyzing that Excel sheet, recommendation system is suggesting some product or some item or some music or some news or some subject. So what should be the question in the database? In database consists of many things, right? If I take your Facebook data set, how many posts you have done, how many likes you got in each and every post, how many share you got in each and every post, everything will be there, right? So if you see, the fundamental question of the database is that which information do we use to make recommendation? Which information is required, which information is not required. Try to understand, it's a data analysis. If you do some kind of data analysis, something is unique. If some attribute is unique, which attribute is unique in the student case? Student mobile number may be unique, right? Student roll number may be unique. If something is unique, that is not required for data analytics, right? Why it is not required? You cannot establish a relationship between the first person with the second person, right? You have a unique attribute, I have a unique attribute. How to find the similarity between two users? It is practically not possible, right? So if some unique attribute is there in the database, okay, or in the Excel sheet, in each you check the column of each and every database. Each column represents a particular attribute. Okay, like each column indicates a particular post of the Facebook. So if you have a unique thing, that is of no use. So such information we will discard before entering into the database. Okay, or after entering the database, we have to clean the database. that information will not give you any relationship between two different users, right? For example, mobile number is also unique, right? But one person will say that I am using, let's say, Geo mobile phone. Another person is saying I am using Vodafone, right? So they are using different one, right? Another user is maybe used Vodafone. So I can establish the relationship between these two users because they are using the same network provider, right? So on that perspective, you can say that mobile number is helpful. But if you are assuming that you will establish some relationship between the two mobile number, that is of no use, right? So database associate with a very important question. The question says that first you have to filter which information is important, which information you have to discard. Similarly, there is another question associated with the second component, that is recommendation system, which says that how to implement the recommendation system. Once I have decided which information is important, which information is not important, then finally I have to decide how to implement, which programming language I will use, which programming language will be helpful to my context, that you have to decide using this particular component, right? Third component is that suppose I have implemented a particular recommendation system, right? For our student in the education system, I have designed a recommendation system which will take the grades of first 2 years, right? In the third semester, we have two elective course, so it will suggest which two elective course is best for a particular student, right? That you have decided, and you have decided Python is the language. Is the language I will implement the recommendation system. So first two things is clear, right? Which information is important? First information is important is that I have to select two elective subject for a particular student. That is my information I have to. That is the information I have to get from a particular data, right? Data is nothing but your mark of 20 subjects. And recommendation system also you have decided which programming language you will use, and how many students are there, what is your database size, everything you have. What is the guarantee that your recommendation system is giving correct result, right? That's why you need every system, whether it is a mechanical system or electrical system or a computer system. I need evaluation of the system. Until unless I will evaluate the system, I cannot say that that particular system is working fine, right? Like any algorithm we are proposing, any paper we are reading, there is a evaluation matrix, right? Whenever you are comparing your approach with some other approach, you are taking some measure in which you are saying if this measure I have compared for the previous algorithms and my algorithm, previous system, and my system is performing better than the previous one. That's why you have to decide whatever the recommendations a particular recommendation system is giving, whether they are giving the correct one or not. For example, for the time being, I will tell you, suppose Flipkart sent me a particular mail. In that mail, they have mentioned you purchase a computer system, but I am not interested to purchase any computer system. So their algorithm failed, right? Because I am nowhere related to computer system, but they are sending the computer related mail. That is of no use. But if I am interested in computer, so what happened? I am interested in computer. They are also suggesting computer system to us. So their evaluation is, if you evaluate such a recommendation system, you will get a better accuracy, right? Similarly, whatever the choice of a particular student, if such type of elective courses I can provide by developing a recommendation system, then I will say that my recommendation is performing better. Now, in the rest of the slide, I will only focus on these particular points, right? But I will address only 2 points. With that Excel sheet, whatever I have said, you have to answer this question, that is how to implement a recommendation system. So I will focus the rest 50 slides about this, which information is important and how to evaluate a recommendation system without focusing on how to implement a recommendation system. Because implementation part you have to do. I will help you, but you have to do in the next session. So now, let us see. First question is coming. Which information do you use the make recommendation? Right? This question is associated with what? Can anybody answer? Out of 4 components, which information do you use to make recommendation? It is associated with which component? Can anybody write in the chat window? I have 3 questions, right? So first question belongs to which component? Database, yes, exactly, database, right? Database. In database, I have mentioned the question: which information do we use to make recommendation, right? Now come to this particular question, right? So we'll go inside the database. We'll see what is there in the database, right? So later I will tell you about the different types of database. But now I'll tell you we are more focusing on the content-based information. What is content-based information? Before going to the content-based information, you know what is data, right? You are storing some file, okay? You are storing some, you are typing something, you are storing in a document file, you are collecting the results of the student. These are called the data. So whenever I process these data, for example, I want to find average of 5 students, right? Some today we have test out of 20, right? Out of 20, I'll calculate how much you have secured. So I similarly I'll calculate for 195 participants, right? Then I will find the average mark, right? I'll find the average mark, right? Average is a performance measure in order to calculate the average of a particular class, right? So if you see that average is called as our information, right? These are called as data. 195 participants mark is called data, and I am processing this data to get the information. For example, if you see, these are a set of movies. Okay, these are 5 movies. 1, 2, 3, 4, 5 are these are the movies. If I focus on a particular movie, okay, each movie has a genre, each movie has a director, each movie having a running time, each movie have a summary. Okay, each movie is a having a duration. Okay, so these are the various attributes of a particular movie. Like you know that something is called as metadata in computer science, right? Whenever we are talking about metadata, that is nothing but data about data, right? So what is data about data? So let me take an example. I have a word file. That is a word file 1, first word file. There is a second word file. What is the common among these two word file? The common among these two word file is this word file having a name. First word file is having a name. Second word file is also having a name. Similarly, these two word file having some permission. Permission means whether I can read that particular file, or I can write in that particular file, or I can do some kind of manipulation, okay, append. So these are the permission is another file. These two file having some size, right? One file is, let's say, 10 KB, another is, let's say, 15 KB, like that. So these are called as our metadata, not data. Data is whatever there inside this file, right? That is considered as a data. But I am not interested for the data. I am interested for metadata, right? So I have to choose some common properties of these word files, and I will see how the information is varies with respect to one header file from another header file. For example, if you focus on this is a movie, okay, this is another movie, right? Both movie there is a genre, right? Or both movie there is a title, okay? Movie title. Both movie there is a director. Both movie there is a running time. Both movie there is a summer. Both movie there is a actor. Both movie there is a actress, right? So these are the common attributes. I am interested for these attributes. Why I am interested? Because, for example, this movie is a drama movie. I am writing D for drama. This movie is a romantic movie. I am writing a romantic movie, right? Romantic movie R. Tomorrow, another movie is released in the box office, right? Another movie is released. That movie is a romantic movie. So I can say these two movies are more or less related because both are romantic movie, right? So if a user is interested for romantic movie, or if a user has already seen this romantic movie, then I suggest that user that you also go for this romantic movie, because that user is interested for romantic movie, right? Another suppose example, next week another movie is released. That movie is a drama movie, right? I know I know the users who are interested for the drama, right? So those users I will post that this movie is a drama movie. So you please watch this particular movie. So these are based upon the various content of a particular item. So this item may be a movie, item may be your book, item may be a subject, item may be anything. Similarly, you can also analyze feedback. The feedback may be there in the database, right? Your database may consist of these metadata. Our database also consists of various type of feedback. Feedback is, there is a explicit feedback, there is a implicit feedback. Explicit feedback, we are asking user to give the feedback, right? Suppose I have said to feedback form, So I requested you to please fill up the feedback form. That is called an explicit feedback, right? Similarly, there is another type of feedback that is called implicit feedback, right? Although in the next slide I will tell you more clearly. Let us see here. So explicit type of feedback is nothing but a feedback, a system where we rely on the user giving us explicit signal about the preference. For example, you purchased a particular item from Flipkart, then you gave a rating of 4 out of 5. So you are giving an explicit rating, right? You are reading a particular article, there is a thumbs up button and there is a thumbs down button. So you clicked on the thumbs up button, right? So these are called the explicit signal. Okay, both type of feedback is important. Explicit feedback is also important. Implicit feedback is also important. But explicit feedback, we are giving an explicit signal, right? Like we are mentioning that this product is 4 out of 5. This lecture is 3.5 out of 5, right? That lecture is 5 out of 5. Like that we are assessing, right? So such type of things are called as explicit signal, right? So user can provide a explicit feedback or user can provide a implicit feedback. Let us take what is implicit feedback. Implicit feedback is nothing but when we click a particular thing, when we click, we are posing some query, or whenever we are watching something in which we are inferring a particular preference. For example, I am clicking some agree to book a particular ticket, but in the side screen of that particular website, right? In the side of that particular website, while I'm visiting XYZ to book a particular ticket, something is coming, right? So I am clicking there, right? So that is a click, right? Or there is a small video is playing, okay? So I am watching that video. So these are called as your explicit signal, right? You are no way concerned because you are interested for XYZ website. You are not interested for these side ads, right? But is the side ads are that much interesting, so we are clicking on that, right? That type of signal is called as an implicit signal. So you have to collect both explicit signal and implicit signal in order to provide recommendation. But note that when you have lack of clicks, you have lack of preference. If somebody is not clicking, then implicit part you cannot infer. So this also there in the database. Third part is there is a demographic information, right? In Flipkart or Amazon, some products are there that is only used by female persons. Some products are there that is used by male person, right? So I can say gender wise I can classify the items also, right? There is a female item that may not be purchased by a male, right? Somebody may purchase, but I'm just classifying it, right? Whether it is a male type of product, male oriented product, or a female oriented product. Somebody will say that these products, whatever products available in the Flipkart, that is only applicable to 0 to 5 years. Okay, starting from 0 year to 5 years. Right, like diaper is there, right? Diaper is used in between 0 to 5 years. So that product is applicable only to 0 to 5 years, right? Similarly, some products are there that is applicable for let's say 20 years to 30 years or 30 to 40 years, 40 to 45 years. Like that you can classify. So that information also I have to collect. Some products are there that is associated with profession. For example, book is generally purchased by researcher or if a faculty member, right, or a student, right? So based on that also you can infer some kind of information. Last one is called as our social information. Social information means what? Suppose one of my friend is watching a drama type movie, then I am also going with my friend, right? Because I also like drama type movie, right? So recommendation system establish a relationship between first user and second user. For example, here second user, fourth user, it is establishing some kind of relationship. Both are liking drama type movie. So if a new drama movie is coming and that drama movie is watched by this particular user, then it automatically suggests that drama movie to the second user, right? So such type of recommendations also you can make, okay, based upon the social information. So these are associated with which information do you use for make recommendation. That is purely your problem specific. So what information you will consider for generating the recommendations. Now, so if you come to the computer science term, okay, database term, we generally called as content-based information. If you see in the content-based information, we are interested for item ID. Item ID is nothing but your movie ID. Each movie is a ID, right? I will say movie 1, movie 2, movie 3, like that. Each movie have a genre, each movie have a director, each movie have a actor, actress, each movie has a summary, each movie has a running length, each movie has a cost, okay, budget, everything is there. That I am maintaining this thing in the database. So those who are not in the CS background, they may not understand this thing, but they indicate that we are maintaining everything in the form of a table. You can assume that each movie I am representing in a row of a particular Excel file, and these are I am representing a column in the Excel files. Then you will understand that what is represented in for this particular slide. Similarly, explicit feedback means what? In explicit feedback, I will record which user gave how much rating in a particular item. Suppose I have purchased 5 items from my 5 item from Flipkart. So I gave some rating to that products, right? That I will record using this particular database. User ID is there, item ID is there, then I am mentioning the rating. Similarly, there is a implicit feedback, right? Implicit feedback, you have to see that which user is clicking which website, which user is watching which type of video, that also you can see. So, as a part of this feedback system, you can also calculate, for example, let's say user 1 is listening a music 30 times, right? It happens that some song is one song is very much popular and it is my favorite song, so I am listening this song multiple times, right? So I can say user 1 is listening a particular item 1, okay, or a music 30 times, right? Similarly, demographic information is nothing but our age or our profession, our gender. So in our database, I will mention user ID, age, whether he is a male or female, or what is the profession, whether belongs to teaching profession or business profession or XYZ profession, that I have to mention. What do you mean by social information? Social information means I have to establish the relationship between two users. How user 1, user 2 are related, right? Suppose user ID 1 and user ID 2, the trust value is 0.5. That I can maintain here. Okay, user 1, user 2, the trust value is, let's say, 0.9. So 90% they are trusting each other, right? So I have to establish the relationship between two different users. So that is associated with our friendship, right? So, or you can say that which user is associated with which other users, right? Suppose in you can say in my Facebook, let's say 4,000 friends are there. So you can maintain user 1 is related to these 4,000 friends. In order to establish the what type of relationship you have with 4,000 users, 4,000 users, right? Okay. Now coming to the types of recommendation system. The recommendation system is of two types. One is called collaborative filtering based recommendation system. Another is called content based recommendation system. So these are the very two different type of recommendation system. So you can choose one of them to as a part of your research work. So first you have to classify whether you want to watch in recommendation system, collaborative recommendation system, or content based system. But before going to these two systems, let us try to understand what is the difference, right? So as the definition suggests, collaborative filtering approach builds a particular model from users' past behavior. What is the meaning of past behavior? You have purchased 4 items from the Flipkart. So that is your past behavior. You have learned 20 subjects as a student in your past. That is considered your past behavior, right? So based upon your past behavior, I am going to build a particular model. So that is called as my collaborative filtering approach. Let us take an example to understand the difference between these two. Then I will come back to this particular slide. Now see this example. This is a very beautiful example. For example, C liked a particular item or C liked a particular book, right? In the same book also liked by a particular person. What I mean, these two users like a particular item or a particular product or a particular book or a particular subject. As these two users like the same item, right? Same book or same movie or same music. So what happened in the next day, she read another document, or she purchased another item, or she listened another music. So the same music I can suggest to this particular user, right? So for example, user 1, user 2 watch a particular movie, Robot, right? Next, what happened? User 1 is watching another movie called Robot 1 or Robot 2. Okay. So as both users had watched a Robot movie, and this particular user is watching Robot 2 movie, so automatically Robot 2 you will suggest to your second user. So that is called as collaborative filtering system, in which user's profile is very much important. Without user's profile, it is practically not possible to go for collaborative filtering system, right? So collaborative filtering system establishes relationship between two different users, right? If a user is interested in one item, another user is interested in the another item, so they can be put in a single basket, so that if one of them is using a particular item, the same item I can suggest to the other users. So that is called as my collaborative filtering system. Now, coming to the content-based system, what content-based system says? Content-based system approach utilizes a series of discrete characteristics. What do you mean by discrete characteristics? Like I told you, human being is having two eyes, right? We have ear, we have nose, we have tongue, we have hand, legs. So these are the various characteristics of a human being. Like a car is having headlights, steering, brake. So these are the various characteristics. Similarly, it focuses on a series of discrete characteristics. Okay, of whose discrete characteristics it is focusing? It is focusing on item, not the user. Try to understand. First one is focusing on the user, right? Second one is focusing the characteristics associated with a particular item. What is the characteristics associated with a particular item? You can say a particular item, the cost is a characteristics. It belongs to whether the book or entertainment or cookware or some other or beauty product. That is also one of the characteristics. So that you have to categorize, right? In order to recommend why you are doing this characterization of the item, because you have to recommend some additional item whose additional item, those are having same properties as the previous items. Okay, try to understand. In each and every item you have to analyze the discrete characteristics, the characteristics of the item. Okay, why you are analyzing these discrete characteristics? In order to suggest future items which is having the same characteristics as the previous items. For example, let us see this example to make your idea clear. So here we have a single user. We don't have two users. Like the previous system I told you, we have two users. Here we have a single user. That single user is interested in this particular item, or interested in this particular book, interested in this particular music, interested in this particular movie. It may be anything. So, but this movie is same as this particular movie. The characteristics of this particular movie is same as the characteristics of this particular movie. Like I told you, this movie is a robot movie. First one is a robot movie. Second one is robot 2. Okay, second part of the robot, right? This user is interested in the robot movie, right? And robot movie is associated is similar properties with robot 2 movies. So automatically I will suggest robot 2 movie to the user. Don't be confused. In the previous case, X user is interested in one item, Y user is also interested in one item. As they are interested in the same item, what I will do? If one of them is interested in this item, I am suggesting the same item to the next user, the other user. That is the previous system, that is collaborative system. But in content-based system, what we are doing, if a user is interested in a particular item, I will find the item, other items, whose the items that are having the same properties as the previous item. Like I have selected robot 2 movie, which is having same characteristics as the robot movie. If such as things happen, the second movie, that is robot 2, is suggested to this particular user, right? So if you have any doubt, please write in the chat box about this difference between the collaborative system and content-based system. So collaborative system, we require more or less related to the user, but content-based system, we are more or less related to the item. So we require both, user and item we require, but these things we have to take an assumption. So you cannot say that collaborative system is better than the content-based system, or content-based system is better than the collaborative system. Both are required, but based upon what, based upon that you can apply collaborative system or content-based system. Is there any question? Okay, thank you very much. If concept is clear, then I'll proceed. Okay, so now, so if you go to the collaborative system, what we are interested? We are interested a user and a item and a rating matrix. Generally, we call it a rating matrix. I'll tell you in the further slide so that the idea is more clear. So we are interested in set of user ID, set of item ID, and if an item is purchased by a user, like I have purchased computer system, then how much rating I have given, that we have to mention in this rating table. Similarly, you can also say that I have listened a particular music for 30 times. That you can mention here. So such type of data, if it is given to you, then you can apply collaborative filtering based recommendation system. Now come to this example in order to clear your idea. Throughout this slide, I will use 11 users. For example, I am considered a subclass of the system. I mentioned in the definition of recommendation system that we are focusing on a subclass of information filtering system, right? So throughout the slide, we'll consider 11 different users, right? Just to assume that there is 11 users are there in the Facebook, or 11 users are there in Amazon, or 11 users are there in the Flipkart, and total number of items, or total number of posts, or total number of share, or total number of like exist in the Flipkart, or sorry, your Facebook, or total number of tweet in the Twitter, or total number of items they can purchase in the Flipkart or Amazon is 15. What it indicates? User 1 has purchased item number 1 and user has given the rating is 5 out of 5. So we have considered in the entire slide that the rating you have to give in between 1 to 5, right? You have to give after purchasing a particular product, you have to give the rating is 1 to 5, where 1 indicates what? 1 indicates the product is not good. So you can say bad, okay, or you can say very bad, right? So what is 5? What is 5? So 5 is nothing but the product is an excellent product. It meets your expectation, right? So similarly, if you see user 1 has purchased item 1, he gave the rating 5. User 1 has purchased I2, gave rating 5. Similarly, user has purchased I3, I4, I5, has given the rating 5. But user 1 has purchased item 7, but it is giving rating 2. What it indicates? User 1 do not like item 7. So there may be a packaging defect, there may be a product defect, there may be anything, right? So finally the user is giving 2. So what is our objective in this recommendation system? Which item is not purchased by user 1? Like I6 is not purchased, I8 to I15 is not, I8 to I15, yes. So these items are not purchased by user 1. So you have to predict the rating of I6 followed by I8 to I10. So I15. So these items are either not purchased by the user, or user has purchased and not giving the rating, or not submitted the rating of that particular item. So try to understand this item 6 to item 8, I15 is not purchased item. That is the first case. That is maybe unpurchased item. Second case, user has purchased the item, but first case is it is unpurchased, right? It is not purchased, not interested in that item, or not purchased that item. Second one is purchase the item, but feedback is not submitted, or you can say rating is not given. Okay, so you have to predict the rating of I6, I8 to I15 for user U1. For example, if you see here, what did this blank indicate? This blank is corresponding to which user? Just like you assume that this is an Excel sheet, right? This is a blank one. What blank indicates? This is, if you see the row of the blank one, it is user 2. And column of that blank, then it is I10. It indicates that user 2 has not rated item I10. Why he is not rated? Because he has not purchased the item, but he has purchased the item, but till now he has not submitted the rating. Right? So generally this matrix is, in computer science term, we call it a sparse matrix. Right? You know, in data structure we call something as a sparse matrix. So for non-computer science user, I will tell you, in a particular matrix, as you know mathematical concept, if maximum values are 0, okay, maximum values are 0, like in this matrix, if you see, this is a type of matrix whose dimension is what? 11 cross 15, where 11 number of rows are there, 15 number of columns are there, 11 is nothing but number of user, 15 is nothing but the number of items, and most of the spaces are blank, or most of the spaces are 0. 0 indicate that user has not given any rating till now, is not given. Such matrix are called as a sparse matrix. Some value you know and some value you don't know. Similarly, you see here what it indicates. This 4 belongs to which one? 4 belongs to U6. Which item? I7. What it indicates? User 6 has rated item 7 with a rating of 4 out of 5. Right? Similarly, some websites are giving rating out of 10, but in this entire slide, I will take the values in between 1 to 5. And blank indicates the user has not purchased the item. Now see similar kind of matrix. This is also a similar kind of matrix. Previous case, I have taken the scale in between 1 to 5, where 1 indicates very bad and 5 indicates it meets your expectation. That is excellent. So in this matrix, what we are doing, we are not taking the range is 1 to 5. Previous case, it is 1 to 5. In this case, we are taking the range is -1 to +1. What -1 to plus indicate? -1 indicates user don't like that product. So if you see U1 I2, what is the value? -1. What it indicates? User 1 do not like item 2. Okay. Similarly, if you see the user 1 I1, what it indicates? User 1 like the item 1. Okay. If a user has not purchased a particular item, then what it will be? It will be the blank one. Like if you see this blank one indicates user 2 has not rated item 10. So it is not compulsory in the recommendation system. You will judge from 1 to 5. So somebody will say that you give your rating binary, either -1 or +1. I don't need any other thing. Whether you like this lecture or you don't like this lecture, right? Similarly, see here, -1 indicates what? User 2 does not like the item number 7, right? Similarly, +1 indicates U6, its corresponding row is U6, corresponding column is I6. So user 6 like the item number 6. So your matrix may be in the range of 1 to 5 or it may be -1 to 1. So let us see what is the range in the next matrix. Now, I am using, let's say, Geo7 app, right? You are very familiar with Geo7 app. Those who are not interested, downloaded this Geo7 app, let us consider YouTube. In YouTube, let's say, I am watching the songs of a particular singer, right? Let's say some singer in Bollywood, right? So I have listened to the music one, let's say music ID is 1, right? First music of that particular singer, let's say 50 times. What it indicates? It indicates that music 1 is music 1 I have listened 50 times. So here the range is not 1 to 5. Here the range is not -1 to +1. Rather than how much time you are listening that particular movie, that is showing here. For example, if you see here 15, what 15 indicates? The corresponding row is U6. Corresponding column is your I7. What it indicates? User 6 has listened to the item number I7. How much time? 15 times. Here what 0 indicates? 0 indicates that user 2 has not listened the item number 10. Right? Similarly, whenever you are listing a particular movie, you have to increase 1 value. Right? Let me see if there is a question. Somebody written something in the chat. Many times a user do not give the rating even they purchase the branded items of a particular product. That is true, very true. However, some rose products are overrated by manipulation by manufacturer or seller. That is also very true. So how to avoid such scenario? Very good question. The excellent question by Dr. Tapas. Right, maximum products, whenever we are launching a new product, generally Flipkart or Amazon, whenever they are launching a new product, what they will do, they are doing some kind of proxy rating, right? So in order to, they will say that, for example, I'll tell some people, right, that you write good feedback for our workshop, right? That is a fixing type of thing. Such type of things are done by Flipkart and Amazon also. So such type of in order to analyze such thing, you need that whether that particular user is a genuine user or not, whether the user is frequently purchasing the item or not. Various factors you have to consider in order to know that whether the rating is a real rating or fake rating. So it introduces another area of research that is called sentiment analysis. So whenever a user is writing, right, whether he is writing for that the user has not never commented anything, right? For a new product, he is writing something. So such type of analysis you have to do. Or whenever a user is posting something, you have to analyze its sentiment, a positive sentiment, negative sentiment, or whether it's a fake information or not fake information. So many algorithms are there that is related to the social network, which is not covered in this particular slide. So that's why, so sentiment analysis will help you to analyze that such ratings. Just like implicit feedback, number of times listen the song. Yes, yes. Implicit said feedback we are not taking by means implicit feedback is not known to user also. Sometimes you are clicking some videos or some images, you don't have such knowledge, right? But that is recorded. Okay. So manufacturer sellers are doing such type of thing, right? So in order to avoid that, so many techniques are there that is related to sentiment analysis, right? Which is we are not covering in this particular lecture, right? I will not focus on that particular part. Okay. So, okay. Next, in the content-based information, what we need in the content-based recommendation system, I told you, we are interested for what? We are interested for the discrete characteristics of two different items. So, I have to see in each and every movie, which movie is much more popular, right? And what is the characteristics of that particular movie. Once I know the characteristics of the particular movie, I will find a similar movie which is having the same discrete characteristics and I will suggest it. So for this case, we are maintaining with respect to a particular movie, what is the genre of that movie, director, what is the running time, what is the summary of that movie, and how many times a user has consumed that movie. It may happen that the user is watching a movie multiple times. That also you have to record. Now come to a very small example, right, in which we will see how this collaborative filtering system and content-based system works. So let us consider a e-commerce website, right? E-commerce website like Flipkart and Amazon, they are selling thousands of smartphones. But in this example, I will restrict to 5 smartphones with 2 different features, right? I want to purchase a smartphone, but I have to consider only 2 features. One is battery, another is display. No other features I will consider. So how a user profile is look like, how a item profile will look like, how a user item matrix look like, we'll see here. So this matrix is more or less related to your item. That's why it is called as item featured matrix. It gives the idea about your item, or it is called as your item profile, right? Item profile. This is not user profile. This is item profile. So in which I mentioned smartphone 1, smartphone 2, smartphone 3, smartphone 4, smartphone 5. So I am rating each and every smartphone in terms of 2 features, and the values are ranging from 0 to 1. Right? So it indicates that smartphone 1 battery is 0.90, means battery is good, but display is not that much good. Smartphone 2 battery is excellent, but display is not good. Smartphone 3 battery is good, but display is not good. Smartphone 4 battery is not good, right, but display is good. Like that, you have to collect the item feature matrix. So this item feature matrix is given to you in the content based system. Okay, if content based system, but the user item matrix, okay, and user profile is given in the collaborative system. So once you have this information, you can do some mathematical calculation in order to generate the other matrix. So there are 3 metrics. One is item feature matrix. Next, this one is a user feature matrix. In user feature matrix, what happened? The first one, this one is nothing but a set of users. So you have information about set of user. Aman is a user, Bob is a user, Chandan is a user, David is a user. And how, whether they are liking the battery, how much they like in the battery and display part, that is written here, right? They are like Aman, he prefers battery, okay, over the display. Similarly, Bob, if you see, Bob likes, he likes a long lasting battery, okay, and display is somehow, if it is less also, it is okay. Like David case, David like the display but not the battery, right? So similarly, this is called a user feature matrix or user profile. So user profile gives idea about user, item profile gives idea about your item matrix, and there is another matrix that is called as your user item rating matrix. So one side you have user, another side you have smartphones, that is your item, and the item whatever purchased by the particular user is written here. For example, Aman has purchased the smartphone S1 and smartphone S2. The rating is 5 and 5 respectively. But these 3 items are not purchased by Aman. Okay. So Bob case, Bob purchased smartphone 1, smartphone 3, but not purchased S2, S4 and S5. Like that. So this is called as your user item matrix. Okay. So there are 3 things. Try to understand 3 things are there. One is item based feature matrix or item profile. Second one is user profile, that is user feature matrix. Third one is your user item matrix. So what I will do, Here I will, here as the item is not given, here two things is given to you. It is a collaborative system. Collaborative filtering system, rating matrix is given to you, and it is given your user profile is given to you. Item profile you have to generate, right? Two things is given. Remember, one is your rating matrix, second one is your user profile. What you have to generate? Item profile. How will generate? So with respect to smartphone S1, let me assume that there is a information feature vector, let's say x1, x2, right? So I have taken here, based upon the some research paper, I have taken an equation that is u1 s1 transpose is 5.0. So this value is 5. What it indicates? u1 s1 transpose is equal to 5. Why I have taken transpose? That is very much important, right? If you see user 1 values are in, I'll tell you in the next slide, it is better. So let us see, use what is this 5? This 5 indicates, or this 4.5 indicates u2 s1 transpose is your 4.5. Similarly, u1 s2 transpose is 5, right? So like that, here you can say u3, the corresponding row is u3, corresponding column is s2, so u3 s2 transpose is 0.5. So in the using these particular things, we have to generate some equations, right? By if you solve that particular equation we did in our childhood, right? Solving two unknown variables, we require two equations. If you get two equations, then you can generate the item feature matrix or item profile. Now come to this example. So now you have u1 s1 transpose is 5.0. You collected this one from your user item matrix, right? User item rating matrix. So what is user 1? User 1, you know that user 1 likes battery in comparison to display. So I am directly placing u1 is nothing but 0.90 to 0.10. And S1 is what? Smartphone feature. Smartphone feature we don't have, because item feature we don't have. We have two things only. One is user profile, another is your rating. The second one is unknown, right? So I am writing x1 x2 transpose. Remember, this matrix is a 1 cross 2 matrix, right? If I will take another 1 cross 2 matrix, you know that multiplication is not possible, right? That's why they are taking transpose. In the research paper, they have taken transpose such that this matrix will be converted to a 2 cross 1 matrix. So finally, whenever you multiply 1 cross 2 matrix, 2 cross 1, finally you will get a 1 cross 1 matrix. So it is a matrix multiplication. You know that column of the second one is should be matched with the row of the second matrix. Column of the first one should be matched with the row of the second one. Then only the matrix multiplication is possible, and the rest two are your resultant matrix. So here you know user profile. User profile is 0.90, 0.10. You do not know S1 transpose. That's why you have taken variable x1, x2 transpose, and this is 5.0. So if you multiply 0.90 into x1 and 0.10 x2 is equal to 510, you will get. This is your first equation. Similarly, you know u2 s1 transpose is 4.5, previous slide, second rating, right? If you see this one, you have no, right? u2 s1 transpose is 4.5. So you know here what is u2? u2 is nothing but your 0.80 and 0.20. User 2 also likes battery in comparison to display. So it is 0.80 to 0.20. And this is your unknown equal to 4.5. So now if you multiply these two, you will get 0.80 x1 plus 0.20 x2 is 4.5. So now you have two equations with two unknown. That is x1 is a unknown, x2 is a unknown. So you can solve these two equations. How will do? See here, it is 0.10 at 0.20. If I multiply 2 here, this is your equation number 1, right? This is your equation number 2. If you multiply equation number 1 with 2, so what will happen? It is 1.80 x1 plus 0.20 x2. 5 into 2 is 10. Second, equation 2 I will multiply with 1 only, or I will take as is, right? So I will not modify anything. 0.80 x1, 0.20 x2, 4.5. If I subtract it, these two terms will be cancelled out, right? And 1.80 minus 0.80 x1. So it is nothing but your x1. 10 minus 4.5. You will get how much? 5.5. So if you solve it, you will get x1 value is 5.5, x2 value is nothing but your 0.5. Now you got the smartphone 1 feature matrix is 5.5 and 0.5, which will be helpful for you to make further recommendation. Similarly, you can take here. You can take U1. Sorry, here you can take U1 S2 transpose, U3 S2 transpose in order to generate the profile of S2. U2 S3 transpose, U3 S3 transpose, right? Then you will get the profile of S3. So I am assuming that you can do after the end of this lecture. After calculating that, what I have to do, whatever value I am getting, right? So I have to find the maximum of that. That means maximum of U1S1 transpose, maximum of U1S2 transpose, U1S3 transpose, so on, right? So if you multiply that, you are getting the value 5, 4.99, 4.95, 1 and 2.9. It indicates that user 1 like smartphone 1, smartphone 2, smartphone 3, smartphone 5, because 2.9 is greater than 1, then smartphone 4. Although he has purchased smartphone 1 and smartphone 2, so we'll cancel these two. If you need another smartphone, the next new model phone we have to recommend to first user is S3, right? Is it clear? So can anybody write in the chat window? I'm giving you 1 minute. Yes, okay. So you have to solve the equations, right? So these values, once you solve the equations, as I mentioned here, U1 S2 transpose, U3 S2 transpose, then you will get this value. Similarly, S3 case, you have to do U2 S3 transpose, U3 S3 transpose, so that you will get this value, right? Like that you have to process. Okay, so that you can generate your item profile and can suggest the item. Coming to the content-based system, what is there in the content-based system? Content-based system, you have user profile, you have item profile, you know set of user, you know set of item, but you do not know the mapping of U to S. That is nothing but your rating matrix R. So you have seen the rating matrix in the collaborative system. So that rating matrix is not available here, but you know user profile, you know your item profile, right? Smartphone profile. So as you know these things, you will simply apply, you will multiply this one with this one, right? You can multiply this one with, right? Smartphone, some smartphone one perspective, irrespective of the user, you can apply like this, or you can apply user one with smartphone one, user one with smartphone 2, user one with smartphone 3, user one with smartphone 4, user one with S5, find the maximum, so that you will get which item you will suggest to the content based system. So see, the same calculation I am doing, but no need of any equation, as you know the user profile and the item profile. I am simply multiplying. I am taking user 1 profile. What is user 1 profile here? User 1 profile is 0.90, 0.10. So I am writing 0.9 and 0.1, right? 0.9 and 0.1. What is S1? S1 is nothing but 0.90 and 0.10. So I am taking 0.9 and 0.1. I am multiplying these two. Similarly for U1 S1 transpose, U1 S3 transpose, so on. Then I am finding the maximum of it. Which one is maximum? In this case, the maximum is smartphone 2, 0.9. Second one is 0.89. Third one is your smartphone 1. Next is smartphone 5. Then is smartphone 4. In this way, you can recommend various smartphones to the user. So these are content-based system and collaborative system. Now, another 6 minutes is left. Okay. So in the collaborative system, there is a problem. Now come to the problem. What people are working in nowadays? People are working in one of the problem, although various solutions are already exist of cold start problem.
Sir, 1 second.
Please.
Sir, why we are taking maximum? Why not the average?
No. Maximum means I have to select out of 5 items, 5 smartphone. I have to select one. Out of these 5 smartphones, finally I have to suggest one. One is smartphone 2. If you want to suggest 2, you suggest smartphone 2 and smartphone 3. If you want to suggest 3, S2, S3, S1. That's why we are taking maximum. Maximum to find the ordering. That's why we are not calculating average. Okay. So now let us see the problems. One popular problem of the collaborative system is called cold start problem. Let us take, for example, our Flipkart database is having how many users? 11 users. How many items? 15 items. Suppose a new user is coming. For example, a user needs, for example, a user in order to create an account in the Flipkart, age limit is 18. Today, one person is completed 18 years. So he'll create one account. So if he'll create an account, his number is added as a U12, right? In U12, if you remember the definition of collaborative system, I told you, we can predict the rating based upon users' past behavior. User's past behavior means, suppose a new BTech student is going to join in your institute. You don't have any history, right? Or a newborn baby is going to join in a particular class. So you do not know his past history. Similarly, in the user 12 case, whenever he is joining in the he is joining as a new member in the Flipkart, you don't have any idea which item you are going to suggest to that particular user, right? So that problem is called as a cold start problem with respect to user. So if a new user is joining, as you do not have any past history, if as you are in the admission case also you do not have past history of your student, then it is very difficult to suggest the elective subject or the subjects to or any subject to a particular user. So such problem is called as your cold start problem. Now come to another generalization. For example, Flipkart launched a new product, okay, or Amazon launched a new product, or our Facebook has changed something, okay, some new thing is started. For example, here I have considered item 16 is recently launched. Once item 16 is recently launched, item 16 also do not have any past history, right? So what you will do? Well, which user you will suggest? Item 16 you should suggest to some particular user, but you don't have any past history. So here also the cold start problem will happen with respect to item. Previous case it is with respect to the user, as a new user is joining, and it is also with respect to a item as it is joining, as this item is newly added into the database. So, but if coming to the content-based system, what happened? For example, a new user is joining in the content-based system. Suppose I am joining in some website. So at that time, the user is asking whether you like a drama movie or romantic movie. Okay, whether you like drama type of movie or romantic movie or let's say horror movie. Okay, so whenever I am creating my profile, I am selecting I am liking romantic type of movie. So what happened? Our database in the content-based system has the details, right? Which type of movie, whatever the movie is indexed in our database, each and every movie is what type of movie that is recorded in the database. So I will search in my database which one is a romantic movie. So I will find a list of movies, right? So based upon that list of movies, I will suggest some movie to this particular new user. So the cold start problem is avoided here in the content-based system if you are joining as a new user. Similarly, for example, consider a new item case, right? New item means a new movie is released. Suppose one X movie is released, right? So X movie either belongs to the love category or romantic category, or it belongs to your horror category, or it belongs to your drama category. So in your database, you have idea about which user is liking romantic movie, which user is liking your horror movie, which user is liking your drama movie. So as it is belongs to let's say romantic movie, so I'll suggest that user a new romantic movie is released, so you can see that particular movie. So such type of problem can be avoided in the content-based system, but it suffers in the collaborative filtering approach. So now there is 1 minute of time. So I request all of you to please ask some question. Then I'll start from here and I'll show that implementation. I'll tell you to do implementation. Why do we choose maximum? Okay. So sir, it is cold start. Now in that slide there is a printing mistake. Okay, that I have to correct. It is cold start only, but in this slide there is a typing mistake. Okay, you please refer the top one, that is cold start, not CLOD start, right? It is wrong. So you please correct it. I will correct later. Any other question? How to overcome the cold start problem? Okay, that is the research area, right? People are doing, right? Cold start problem, how do you level it? You can say that, for example, I will tell you, let us see the scenario so the idea is more clear. For example, here I will tell you, once the user is joining, let's say item number 5 is purchased by maximum user. Okay, then I can suggest U12 to item number 5. But I do not know whether I will succeed or not. But one solution may be the item which is purchased by maximum user. So that item I will suggest. That is one kind of solutions. But there are numerous solutions are exist. Also, accuracy is not close to 100%. People are also working in the full stack program. Any other question?